Find the total number of different arrangements of 8 letters in the word tomorrow. Okay. So in tomorrow, we have a single T, 3 O's, a single M, 2 R's, and a single W. Okay, so total we have 8 letters. So 8 factorial upon repetitions is 3 O's are being repeated and 2 R's are being repeated. So 8 factorial over 3 factorial into 2 factorial. This gives us 3,360. Part B, find the total number of different arrangements of the 8 letters in the word tomorrow that have an R at the beginning and an R at the end, and in which the 3 O's are not together. Okay, so first of all, if there's an R at the beginning, an R at the end, we can get them out of the picture. And in between, we have uh, 6 values, 6 alphabets, 1, 2, 3, 4, 5, 6. And now we're going to work on these. We will be completely ignoring this R and this R because there's no other way of arranging an R at the start and R at the front. So you can ignore that. Or you may even do 2 factorial. For the 2 R's, we have 2 R's at 2 places, but then you will also be dividing with 2 factorial because there's a repetition of 2 R's. So you can just ignore it because you get 1 in the end anyway. Okay, so for this space, we don't want the 3 O's to be together, in which all 3 O's are together. So what we can do is we can find the total arrangements of these 3 slots and minus the arrangements in which the 3 O's are together. Total arrangement for this will be 6 factorial divided by 3 factorials because 3 of these are O's, minus the 3 O's are together. So we need to group that. O is together. That becomes 3 factorial. Later we count this as a single O. And apart from that, we have 3 more alphabets. And these combined make 4 factorial. This is one number. This is second. This is third. And this group counts as the fourth number. So 4 factorial. So we'll get 3 factorial times 4 factorial and also divide with 3 factorial because there are 3 O's in here. Okay, so this would give us 6 factorial upon 3 factorial minus 3 factorial into 4 factorial divided by 3 factorial, which gives us 96. So we have 96 different arrangements for part B. Part C. 4 letters are selected at random from the 8 letters of the word tomorrow. Find the probability that the selection contains at least one O and at least one R. Okay, so whenever you have probability in combination, what you have to do is consider each alphabet as an individual, even if there are repetitions. So we have a T, O will count as O1, then M, then O2, then R1, then R2, then O3, and then W. So even if there is repetition, those O's and those R will count as different O's and different R's. That is how probability works. So now we'll have to find the probability that the selection contains at least one O and at least one R. So we're going to take this case first where we have a single O, we have a single R and 2 other alphabets. Now this O gets selected out of the 3 available O's. So we write 3C1 for that. This R gets selected from the 2 available R's. So times 2C1 times we're left with 3 other alphabets. We have T, we have M, and we have W. So that would be 3C2. 2 out of these 3 get selected, and this gives us 18. Okay, next we can also have O, another O, and then R, and then some other number. So that would be 3C2. 2 out of the 3 O's get selected, then 1 out of the 2 R's get selected, and then 1 out of the other 3 alphabet get selected. This also gives us 18. Okay, after that we may have O, 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 and R. That is just a single combination. So that's, no, it's not a single combination. We have 3C3. 3 out of the 3 O's get selected, and then 1 out of the 2 R's get selected, which gives us 2. Okay. Then we may have R, R, and O, which gives us 2C2 times 3C1 times 3C1. That gives us a 9. And we may also have 2 O's and 2 R's, which is 3C2 times 2C2, which gives us a 3. Now we're going to add 18, 18, 2, 9, and 3 together. That gives us 50. 50 is the favorable outcome. So 50 in the numerator of the probability. Denominator is the total number of outcomes. So we are making 4 selections, or we are selecting 4 alphabets out of these 8 available alphabets. So it's going to be 8C4. 50 divided by 8C4 is 5.7.